Let's start today by looking at your homework, and then we're going to get into factoring. I'm going to teach you how to factor today, so thus the video we just watched. So let's go to work. Section 5.4 told you to do the evens. Now, you should have already done these and watched the video, but just to check your work, but I'm going to do them anyhow just to remind you, okay? Start with the evens. We were distributing x times x squared, x times a negative 2 is a negative 2x. How many people got that one right? Excellent. Number 4, 2x times x is 2x squared. 2x times 3 is 6x. How many got it right? Excellent. Number 6, now we have two terms, or a binomial times a binomial. X times x is x squared. X times 2 is 2x. Now I do the second term times both of them in the second binomial. Negative 5 times x is a negative 5x, and negative 5 times 2 is negative 10. And this is what always happens, or usually happens, when I have two binomials, is I get these terms in the middle that are common, or like terms, and I have to combine those. So I end up with x squared minus 3x minus 10. Again, who got that one right? Those of you who didn't, questions? Do you see your mistake? At least. Look, we're about to start working backward. That's why I'm taking my time and doing these. Okay? It's harder to work backward, especially if you can't do it forward. I mean, how are you going to be able to say your ABCs backward if you can't say them forward? You know what I mean? Okay. Number 8. Before I even get into this one, I want you to notice something about this particular one. Those two binomials look similar. Okay, what's different about them? One's a plus and one's a minus. It's 2x plus 1 and 2x minus 1. That's the only difference between the two. Everything else is the same. I want you to notice those, because this is going to be DOS, difference of squares. Okay, watch what happens. And this is what happens on all of these, because this is why you want to be able to identify these. Okay, when I go ahead and distribute, I go 2x times 2x is 4x squared. 2x times a negative 1 is a negative 2x. 1 times 2x is a positive 2x. And 1 times a negative 1 is a negative 1. And then look what happens with our like terms. This is always what happens in DOS, or difference of squares, or when you have these two signs, everything's the same except those two signs are different. Those two middle terms will cancel, and you end up with 4x squared minus 1. It's called a difference of squared because 1 is a perfect square and 4 is a perfect square, and it's called difference because they're separated by a minus sign. So what I'm telling you is, when you see ones that are like this, that are difference of squares, you can, may I erase all this? Are you ready? We can say, hey, this is the difference of two squares. I know this is going to be square this one, 4x squared, and square this, minus 1, and be done. Do you understand that? Does that make sense? It's a shortcut. It's a little knowledge. Let's try one more. Let's go 6x plus 3, 6x minus 3. We know right away that when we multiply, we're going to end up with a difference of squares. So what's my solution? Quickly. 6x squared, or 6x, and square that. Becomes 36x squared. Minus, it's always a minus. It's never a plus. It's always a minus. That's what's called a difference. Minus what? Minus 9. So 36x squared minus 9. Now, I say all that, and I take the time to tell you that, because when we factor and we see two perfect squares separated by a minus sign, guess how easy it's going to be to factor it? I know I'm going ahead here, but watch this. 49 x squared minus 16. See the two perfect squares separated by a minus sign? That's difference of squares. I can factor this quickly as 7x plus 4, 7x minus 4. That's going to be cool. Those will be our favorite ones. Just throwing that out there. All right, let me move on. Number 10. Distribute. X times x is x squared plus 3x minus 5x minus 15. Combine my like terms in the middle. X squared minus 2x minus 15. How many people got that one right? Excellent. And number 12. 2x times x is 2x squared. 2x times 2 is 4x. 5 times x is 5x. That was terrible. Try this again. Plus 5x. Okay. And then 5 times 2 is 10. Got to combine those like terms in the middle. 2x squared plus 9x plus 10. Cool? Questions? Comments? Concerns? Now, that was your homework. That's what you were supposed to do. We've already talked about all of that stuff. Can I insert a page here? There it is. Insert page. Insert. All right. Factoring. Quadratics. Do you remember? Do you remember when it was September? Oh, sorry. Ax squared plus bx plus c. What is that? Standard form. Yes. Do you remember? Ax minus p times x minus q. Intercept form. AKA factored form. Why does it always go away? Sorry about that. Pause. Sorry about that. Lost it from my screen. AKA factored form. So basically, this is what we're going to do. I told you there was one more form that we learned, which was vertex form. I'm not going to talk about that one today. Okay. Basically, what we're going to do is we're going to take quadratics that are in factored form, and we're going to manipulate the equations or change them to where they're in intercept form. Gee, why would I want to do that? Well, intercept form tells me my intercepts, my x-intercepts. What is another name for x-intercept? Well, that is the zeros of the function. That is the roots of the quadratic. That is the solutions. That's what we're looking for. Okay, we want to know where this parabola crosses the x-axis because that's my solutions or my zeros or my roots. Okay, that's what we'll be looking for. So, I think the best way for me to show you is just to start with a quadratic. Let's start with a simple one. The ones that we're going to deal with today all do not have a leading coefficient, but just for argument's sake, the first thing we should do is look for a GCF. GCF. Look for a GCF. That's something everyone should know. What is a GCF? Greatest common factor. For example, let me go to red here. Let's say I have 2x plus 4. Okay? Is there a common factor in 2x plus 4? Absolutely. I could pull out anybody? A 2. 2 times what gets me 2x? Well, x. 2 times what gets me 4? 2. See how I pulled out that 2? How about this one? 3x squared plus 6x plus 9. Does anybody see a GCF in that one? Absolutely. 3. Good. So I can pull out a 3. And what's left on the inside? 3 times what gets me 3x? What am I really doing here? Well, I'm really dividing, right? I mean, 3x squared divided by 3 is x squared. Yes? 6x divided by 3 is 2x. And 9 divided by 3 is 3. So factoring or pulling out a GCF is really just division. Trying to figure out what things were multiplied to get that, okay? That's what factoring means. So the very first thing you should do is look for a GCF. I promise you, if there's a GCF in there and you don't pull it out, you are going to be miserable, okay? I'm going to skip over this for a little while, and we're going to deal with things that don't have GCFs just so you can deal with it, but I needed to address first. If there's a GCF, you better take it out, okay? Because we want to work with stuff that does not have a greatest common factor. I'm not telling you can't do it without taking it out. I'm just telling you a real pain in the neck, right? So, GCF first, always. GCF first. All right. So now, after I find a GCF, I ask myself, is there, lovely, is there a leading coefficient? Okay, is there a leading coefficient? Oh, remember what a leading coefficient is, yes? Okay. And then my answer to that is either going to be yes or no. Today, we're going to talk about the no. Tomorrow or later this week, we'll talk about the yes. Okay? For now, what you need to know is if it's a yes, we're going to do the box method. You can write that down. And I'll teach you the box method later. Okay? Teach you the box method later. But no, if there's no, it's leading coefficient. These are the ones we're going to deal with. We're going to split in signs. Split in signs. Okay. So, let's try one here. Let's go x squared plus 5x plus 6. Now, by the way, these always equal 0. We say this right now, they always equal 0, where we want them to equal 0. That's why they're called the zeros of our solution. I'm not going to write equal 0 down a lot for a while, but later I'm going to put it back in there. Is it okay with that? Just know these always equal 0. So in other words, if it was equal to 2, I would have to move that over there first before I factor it. Are you with me? Okay, so I'm just going to leave that out for now. I'm just going to factor. So the first thing I ask myself is there a leading coefficient? No. So if there's no leading coefficient, what do? Split in signs. I know you don't know what that means now or yet, but let me show you. Split in signs means is I'm going to literally put 2 sets of parentheses, and I'm going to put an x in each. Okay? That's splitting it. Now, signs means this. I'm going to look at this last sign. I'm going to look at that last sign. You remember what I taught you last week about same and opposite? Remember that? Watch this. This thing still works. Check this out. So this last sign is positive. I know my signs in these two sets of brackets are going to be the same. And that tells me they're going to be the same. It doesn't tell me the positive negative. It tells me they're going to be the same. Then I look at this sign, and I see what they're going to be. In this case, they're both going to be positive. Does everybody understand how I got those two signs? So I saw that there was no leading coefficient, and the first thing I did was split signs. Okay, so I split it into two sets of parentheses, and I looked at signs in that quadratic to determine what the signs I split is going to be. Cool? Next, I'm going to find factors of constant. And the constant is the number at the end, right? So let's list these factors. What are the factors of 6? Well, 1 times 6 and 2 times 3. Which of those set of factors can be added together to get me 5? 2 and 3. So I take those two terms and put them right there. 2 and 3. Let me go back to my original color. 2 and 3. Guess what? Guess what? I'm done. This is factored. X plus 2 times X plus 3. What's so bad, was it? Ready to try another one? Yeah, let's go. Let's go. X squared plus 7x plus 12. Okay. First question. First thing I look for is a GCF. That's something that everyone should know, but we're going to skip over that. Okay. So now what? Leading coefficient. Is there a leading coefficient? No. So what do? And everybody said split signs. There's no leading coefficient. What do? And everybody said split and sign. Put two sets of parentheses. I put an X in each. And I look at my signs. This last sign tells me that they are the same. Doesn't tell me they're positive or negative. It tells me they are the same. Then I look in the middle, and it tells me they are both positive. Next, I list my factors of 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. That's it. Now, I'll come back to that later. Okay. Which of those sets of factors add together to give me a 7? 3 and 4. 3 and 4. Done. Come out. So let's say I have this x plus 3 times x plus 4. And that's some function, because that's what we're dealing with right now, right? Who can tell me what my solutions are? Who can tell me what solutions are? Go ahead. 0. Remember, this is f of x equals a times x minus b times x minus q. This is in factored form now, right? Or intercept form. So what are my two intercepts? What are my two x intercepts? What are my two zeros? Not 3 and 4. -3 and -4. That's where it's across the x-axis. Remember, it's the opposite. Remember those signs in there tell us, hey, it's going to be the opposite of what we see. Everybody remember that now? Okay, it's coming back. That's great. Let's do another one. Let's have f of x equals x squared minus 2x minus 10. And I want to solve this, or I want to find a solution, or I want to find x-intercepts. I want to factor it. What's the first step? GCF. There's GCF? No. Now what? Leading coefficient. Is there a leading coefficient? No. So, everybody said split in signs. Split in signs. Put an X in each. Now, what's this negative tell me? Yes. They're not saying they're going to be opposite. So, right there, when they're opposite, I can go ahead and put a plus in one and a minus in the other. Does it matter which is which? Does not. I don't even have to look at the middle one yet. I'll come back to the middle one. When it was positive, I had to look at the middle, and it told me whether they were both positive or both negative. I want to negative here in a second. All right, so now what? List, we already did leading coefficient. We already split line. We've already taken care of our signs. So now we list the factors of 10. 1 and 10, 2 and 5. That it? Okay, which of those come together? Now, my signs are opposite, right? Since my signs are opposite, I have to subtract these numbers. Which set of these factors do I subtract to the 2? And everybody said none of them, right? I can't subtract any of these to get a 2, can I? That means this is not factorable. And that can happen. Not factorable. NF. Yeah, does not mean that there's no solution. It just means it's not factorable. Basically, what it means is it's going to cross somewhere that's not nice even at this point. Okay, there will be solutions, could be solutions. All right, just not something we like. There's other ways, and we'll learn later other ways to deal with it. Yes. No, because the leading coefficient is 1. And if there, we'll tell you this, if there's no leading coefficient, there's not going to be any GCF. That's a great question. All right, let's do another one. Let's say f of x equals x squared minus 8x plus 16. Okay. Is there a GCF? No. There's no leading coefficient. There's no GCF. Okay, is there a leading coefficient? So, split in signs. Put an X in each. This tells me that they are the same. And now I look in the middle and it tells me they are both negative. Cool. All right. List the factors of 16. 1 and 16, 2 and 8. There's 3 and 16? No. 4 going to 16? Yeah, 4 times. 4 is 4. Now, which of those, since my signs are the same, I would add them. Which of those sets of factors come together to get me an 8? 4 and 4. 4 and 4. Cool. Hey, side note, see how these are both exactly the same? This is a perfect square trinomial. We've talked about those in the past, haven't we? Okay, that's a perfect square trinomial. By the way, I could rewrite this down here as x minus 4 squared, couldn't I? Couldn't I? Cool. Doing good? Let's do a couple more. Let's try x squared minus 7x plus 12. This is GCF. Is there a leading coefficient? So, everybody, split in signs, put a x in each. Signs are same, both negative. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Now, I want to take a time out here. I've done all nice, small, easy numbers for us for this list of factors. We're going to get some bigger ones in here. Okay? Here's what I do when I'm listing my factors. One, I list them out. And I like you to list them out for a while. I know, essentially, you can say, all right, what factors of 12 add together to get 7? And you can kind of skip ahead. I'm okay with that in the future. But I'd like you to start by writing your factor down. Just make that your habit. Okay? And here's why I do it. As I write them down, I'm going mentally in my head. See, I don't have to check every number. And if I go in a sequence, it really helps me. I don't know if it'll help you, but it does help me. So I'll start with one. 1 times a number. 2 is 2 into it. Was the number even? If it's even, it goes in. 3, does 3 go into it? Yes or no? How many times? But watch this one. 1, 12, 2, and 6. I don't have to check any numbers between 6 and 12. I never have to check a number between 6 and 12 because there's no number between 1 and 2, is there? So there's no number that's going to be between 6 and 12 that's going to go into 12. That's always the case. Are you with me? So like, let's try a bigger number, like, I don't know, 36. What are the factors of 36? Well, I start with 1, 36. 2 goes into 36 18 times. I don't have to check any number between 18 and 36. Are you with me? What? 3. Does 3 go to 36? Well, yeah, it goes in 12 times. I don't have to check any number between 12 and 18. Are you with me? Does 4 go into 36? Well, in this case, yeah, 4 goes into 36 9 times. I don't have to check any number between 9 and 12. Does 5 go into 36? No. Does 6 go into 36? Yes. How many times? 6. Look, these numbers came together. I'm done. That's usually the way it happens. I know you get some really big numbers and it takes some time. But if you go in order that way, instead of just trying to think of all the factors, you know you're done because when those two numbers come together, you're done. All right. Just wanted to share that. So in this case, it's going to be 3 and 4. So 3 and 4. Cool? All right. Let's go one more. X squared plus 2x minus 35. Okay. All right. Is there GCF? No. Is there leading coefficient? No. So splitting signs. Put 2 sets of parentheses, put an X in each. Now this tells me they're going to be, and everybody said, opposite. So plus here and a minus there. List factors 35. 1 and 35. Does 2 and 35? No. Does 3 go 35? No. Does 4? Hey, no even number goes into any odd number. Ever. Really. Ever. So I could skip all the evens, couldn't I? So 1 was a no, or 1 was a yes, 2 was a no, 3 did not, 4 obviously does not. 5, does 5 go into 35? Yeah, 7 times. Look, the only number I got to check is 6, but 6 doesn't go in because it's even and 35 is not. You know what I'm saying? See how I went down my list and they come together and done? All right. My signs are opposite, so I got to subtract here, right? Which do they come together? Give me a 2. 7 and 5. Now, which one goes where? Here's how it works. The larger number gets the sign from the middle. The larger number, 7, gets the sign from the middle. So 7 has to be positive, and the 5 is negative. Cool. My solutions? -7 and a +5. I want to do one more, and I'll be done. Let's go. X squared plus 5x minus 50. Oh boy. Is there GCF? No. Is there leading coefficient? No. So split signs. There we go. Put an X each. This last sign tells me they are plus and a minus. Opposite. List my factors of 50. 1 and 50. 2 and 25. 3 is not going. 4. No. 5. 10. 6. 7. 8. 9. Done. Which of these come together to get me 5? 5 and 10. And then which one's positive, which one's negative? The larger number gets the sign from the middle. So 10 has to be positive, 5 has to be negative. Questions? That is factoring at its simplest form. Okay? Got a page for you. I'm going to have you to try tonight for homework. Have a good day.